Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 14 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2147. Number of ways to divide a long corridor, right? So this problem is marked hard by LeetCode, but actually it is easy. I can say I will make this problem very easy for you, right? Even you can write your own code after understanding it. Very easy problem actually. So here let's read the problem statement. After a long library corridor, there is a line of seats and decorative plants. You are given a zero indexed string corridor of length n consisting of letters S and P, where each S represents a seat and each P represents a plant. Okay, so like this, something given to you, right? In the corridor array, right? So this type of string is given to you, right? Of length n, right? And it consists of S and P, right? Where S is nothing but seat and P is nothing but plant, right? After that, one room divider has already been installed to the left of index 0 here, and another to the right of index n minus 1 here. Okay. Additionally, room dividers can be installed. Additional room dividers can be installed, right? Additional room dividers can be installed. Okay. For each position between indices I minus 1 and I, right? So it is saying that additional room dividers we can add, maybe here, maybe here, maybe here. Okay, like this we can add, right? At most one divider can be installed for each position between indices I minus 1 and I. At most one divider can be installed, right? Okay, so here I is from 1 to n minus 1. So if your, let's say I is 1, right? So this is 1, this is 0, right? So between 0 and 1 you can install 1. Okay, this is the meaning of this actually, right? So simple, understand it like this. We can install at most one divider can be installed in between, right? Here, here, anywhere, right? It is our choice, right? Now after that, we have to divide the corridor into non-overlapping sections where each section has exactly two seats with any number of plants, right? So each section has exactly two seats with any number of plants, right? So we have to keep two seats, right? In each section there should be exactly two seats. Exactly two means exactly two, not less than two or not more than two. Okay, right? There may be multiple ways to perform the division, right? Two ways are different if there is a position with the room divider installed in the first way but not in the second way, right? And what we need to do, we need to return the number of ways to divide the corridor. Since the answer may be very large, we have to return it modulo 10 to the power 9 plus 7. And if there is no way, then we have to return 0. Okay, nice. So when there is no way, tell me one thing. So here I am saying you have to divide each section into exactly two seats, right? This is what I am saying here, right? Okay, so let's say this example, right? So here 1 2 3, total 4 seats are there, right? So I can exactly divide these 4 seats into here and into here, right? I can do it. But if my number of seats is odd, right? If the total number of seats in my corridor string, right, it is odd, then in that case how I'm going to split in such a way so that I will get 2 2 everywhere? Can I get 2 here, 2 here, 2 here? No, if the number is odd, let's say 7, then in one place I will get only 1, right? Okay, 2 4 6, at least at one place I will get only 1, but in this case answer is not possible, right? Because in each section I need exactly 2, right? So from here one point is clear, that if total number of seats is odd, simply return 0, right? Or or if total number of seats itself is 0, if we have corridor like this, only p is there, right? Let's say there is no seat, then also you need to return 0, right? Then also you need to return 0. Okay, so your base case is if total seats is equal to 0, or total seats, if you divide it with the 2 and you get value not equal to 0, that simply means odd number of seats. In that case simply return 0, right? This is base case, right? Done. Okay, so you have to iterate over your string one by one, all the characters, and just count now how many total number of s are there, right? Okay, this is done. Now here in this case why I'm getting 3, right? So here let's see, s, we have p, then we have s, then we have p and s, right? So in each section I need 2, right? So I can do one thing now. This is one way, right? If I split it like this, right? So I'm going to get ss, and here I'm going to get pp, right? So this is valid, right? This is valid, right? This is one way, right, to split. What is the second way? Second way, if I split it here, right, this is also valid, right? In this arrangement also, in each section I'm going to get 2 seats, right? So here also 2 seats, 2s are there, here also 2s, here also 2s, here also 2s. What is the third way? Third way is if I split it like this here, right, then also I'm going to get 2s in each section, right? So ssp, right, and here sps. So this is valid. Can I split it like this? No, here we are getting 3 and here 1. This is invalid, right? So there are total 3 ways, right? There are total 3 ways. Clear? So 3 is the output. Very simple problem, right? Very simple. Okay, so here split here, or you can split here, or you can split here, right? So see, these are the 3 ways, right? In each section if you see, 2 seats are there, right? Now let's take some bigger example, right? So let's say this is your example, s, p, s, and let's say p, p, s, p, p, s, p, p, s, s. Okay, something like this. So now here if I just give the indexing here, 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index, 7 index, 8 index, 9 index, 10 index, 11 index, 12 index, right? So now here tell me, here if you notice, right, so I need 2 seats exactly, but here let's first make sure that I have s even number of times or not. 1 2 3 4 5 6, yes. So answer is possible. Okay, now here if you see this section, if you see this section, right, so I need exactly 2s, right? I need exactly 2s. So I'm starting from here, right? I see 1s and I see 2s. So in this section I have 2 seats, right? In this section I have 2 seats, right? So definitely I can't split this particular session from here, right? I will get only 1s. I need exactly 2, right? I can't split here, right? So there is no split possible in this part, in this box. There is no split possible, right? Same way here, see, I need 2s. So this is first s and this is second s. right? Here also I have two seats. Tell me, is there any split possible here in between or not? Can I do split here? No, then I will only get one S na here. Not possible. Can I do split here? No, only S, one S I am going to get here, right? Here 2S and then only one S, right? So definitely in this box, if you see, I can't do any split, right? In these boxes I can't do any split, right? So here I'm getting 2S, right? Same way here, if you see, here in this box also we have two seats, right? Here also I can't do any other split anywhere, right? I need 2S. So here I'm getting 2S, here I'm going to get 2S, and here I'm going to get 2S, right? So in these boxes I can't do any other split, right? In these boxes, right? In these sections, right? Okay, so now here how many answers are possible? Okay, so definitely you can do one split here, right? Okay, if you do one split here, you're going to get something like this: SPS and then PP, SPPS, PPSS, right? This is what you are going to get. Clear? PP, SPPS, PPSS, right? Okay, done. Same way you can do one split here also, right? So if you do split here, you are going to get something like this: SPS, then SPSP right here, and then you are going to get PS, PPS, PPSS. Clear? Okay, good. Here also you can do one more split here, right? Here also you can do one more split. Okay, so what you are going to get now? You are going to get SPSPP, and here SPP SPPSS, right? Okay, done, right? And after that you can't do any split here, right? In these sections you can't do any split, right? So that's it. So here, see, this is one box, right? This is one box, this is second box, right? So in between, if you see how many total P's are there, right? In between total P's are 2, right? Or you can do one thing now. Here this is one box and this is other box, right? So this is the end of this box and this is the start of another box, right? So if you do 5 minus 2, you are going to get what? 3, right? And these are the three sections which are possible, right? 1 here, 2 here, 3 here, right? Clear? Okay, in between we can't do any split, right? But from here three results are possible. Same way, tell me here how many results are possible. So start of this and end of this, 11 minus 8, what is the output? 3. Three results are possible here. And what are those three results? Okay, so let's write those three results. So those three results are, let me use this pen. Okay, so SPS, PP, SPPS, one is this, right? PPSS. If I do split here, right, this is one, right? If I do split here, right, then I'm going to get SP, SPP, SPPS, and then P here, then PSS. So this is also possible, right? And if I do one split here, then also result is possible, right? So then I'm going to get what? I'm going to get SPS, PP, SPPS, PP, and here S, and here S, right? So here also I'm getting three ways, right? Three ways here and three ways here, right? Now tell me here, what is going to be my total result? Do I need to do the addition, or I need to do the multiplication between this and this? Tell me, think about it. So here we need to do the multiplication. Why we need to do the multiplication? Okay, so see here, if I am splitting based on this first, let's say, right, if I am splitting based on this, right, so here I'm doing one split, then here for this one split, here I have total three choices. I can go with this, right, or I can go with this, or I can go with this, right? So for this one split, I have three choices here, this one, this one, this one, right? So for this, if I do split here, then I have three choices. Same way, if I do split here, then for this one also I have three choices, right? One here, and one here, right? Here I'm writing these choices now. Same way, if I'm doing split here, then for this particular split, again I have three ways to do split here. That is one here, and one here, right? So for this one, three choices, for this one, three choices, for this one, three choices. So in total, how many choices we have? 3 plus 3, 6 plus 3, 9. So that is why we need to do the multiplication. Okay, clear? Clear this thing? Why we need to do multiplication, right? This problem is actually very easy right now, right? Okay, this is done, right? Okay, so here, what you need to do, if you understand it, right, like this, right, we are just iterating over the indexing, right? So as soon as my seat becomes two seats, right, so this is the ending of this one, then after that, with the start of next s, right, if answer is possible. So here I have to just do this 5 minus 2, 3, right? Then again I need to move further, right? And once I get 2s here, this is going to the end, so I will get 8, and then for the next s I will get 11. So 11 minus 8, 3. So side by side I will multiply 3 into 3 like this, right? This is the way we can solve this problem, right? Okay, so also one more thing here, I am actually only dealing with S only, right? I don't need to take care of this P. How many P's are here, right? So what I can do here, let's do one thing. For these S, right? How many number of S are there? So 1, 2, 3, 4, 5, total S, 6 S are there. So can I do one thing? I just store the indexes of this S. Like first S is at 0, next S is at 2, after that S is at 5, after that S is 8, at 8, after that S is at 11, after that S is at 12, right? So now here, if you notice, first two indexes are for this section, next two S are for this section, next two S are for this section, right? So here I'm just writing the indexes of the S, right? Now I just need to take care of this part and I will get the answer, right? Because this is forming one group, this is forming one group, this is forming one group, right? We need to S everywhere, right? So now it is very easy, right? So let's say this is nothing but my list of integers, array list, right? In array list I have stored the indexes, right? Now here 0 to 5, 8, 11, 12, right? So we have 0 to 5, 8, 11 and 12, right? This is nothing but my array list, right? This is done. Okay, so now what I need to do here, this is the end of first, right? This is the end of first. So let's say I am starting I from here. Okay, let's say I am starting my I from 2 index, right? From 2 index I am starting my I. From 2 index I am starting my I. Okay, so for this section, this is the last index 2, right? And this is the starting 5. So 5 minus 2, I will get 3. Okay, 3, right? Okay, next time I will do one thing, I will make this I jump to here, right? Because this is the next start of the next section, right, like this. So here I'm making jump here, and for this one also I'm going to make a jump here, right? So next time, next start is 11 and previous end is 8, so I will get 3. and side by side I'm multiplying all the values, and since the answer can be very large, so we have to do the mod always, right? So very easy problem, right? That's it. Okay, very simple code, very simple code for this problem. Okay, so that's why I'm saying that this problem we can say of easy level now, right? You can solve it by yourself, right? Even understanding it, how what we need to do, right? So let's write the code. Very easy, right? Let me just maximize the screen here. So first thing here, create one mode, private static final int mode is equal to 1 1 2 3 4 5 6 7 8 9, right? Then after that, list of integer, and let's say seed indices, right? New array list, and then we have to store indices of all seeds. So here I'm just going to run one for loop, int I is equal to 0, I is less than corridor dot length, and here I plus plus, right? And here I'm going to write if corridor dot char at I this value, if this value is equal to s, then I will just add this to my array list. Okay, seed indices dot add I, right? Very easy. Now here total seeds, right? Int total seeds. Okay, so here total seeds, I can simply get the size of this, na? Seed indices dot size, right? And here invalid case is going to be if my total seeds is equal to 0, right? Or if my total seeds modulus with the 2 is not equal to 0, right? If it is odd, then in that case you have to simply return 0, right? This is done. Now you have to calculate the, if answer is possible, you have to calculate the number of ways, right? So just take it 1 because we have to do multiplication, right? And multiply any number with itself with 1, I will get the same number, right? 2 into 1 is 2, 3 into 1 is 3 only, right? So that is by 1. If I take 0, then I will get 0. 3 into 0 0, I will always get 0, right? Okay, now here I have to write index of the second seed in the first section, right? So that is nothing but the ending of the first section, right? Index of the second seed in the first section. So here let's create a variable name like this, last seed of previous section, right? Last seed of previous section. So here I have to write this seed indices dot get 1, right? So this is nothing but last seed of previous section, right? Now I have to process the remaining seed pairs, right? Process remaining seed pairs, right? So here I have to run one loop, int I is equal to 2 this time, right? I told you I start from 2, I less than total seeds, and here I have to do I plus equal to 2 always, right? This is done, right? Now inside this first seed of the int first seed of you can say of next section, right, is nothing but your seed indices dot get this I, right? So for the next section, this is going to the start, right? First seed of the next section, right? Now possible divider positions we have to find, right? So possible divider positions, right? So here let's write possible divider positions, right? Very easy problem actually, right? So here let's say int divider choices, right? So here what you need to do, first seat of next section, copy this, paste it here, minus last seat of previous section. Done. Easy, right? And now you are going to get the number of ways. So number of ways is nothing but ways is equal to ways into the divider choices, and here you have to take the mode, right? Easy. And then after that you have to move to end of current section, right? So you have to update this in last seat of previous section. So this is nothing but the seat indices dot get of I plus 1, right? I plus 1, right? Plus 1 I'm going to reach to the end of this particular section, right? Because I is the start of first seat of the next section, so last seat of the next section is going to be the I plus 1. So I plus 1, I'm just going to update the value of this one to the last seat of the previous section. That's it. And we have to return the number of ways in the end. So return type is int, so I'm going to change it to int, and here I'm going to write ways, right? So now let's run it and see if there are code issues. So see, only 30 lines of code, right? And our all the test cases have been passed, right? Now let's submit it. So see, our solution is accepted, right? And what is going to be the time complexity? So time complexity for this problem is going to be of n only, right? Of n only, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.